Alright everybody, in this video we're going to talk about whether we can get the precipitate when you mix two solutions together. Here is the criteria that we need to use. Okay, you need to calculate the QC and compare that with the KSP. If QC is less than KSP, then no precipitation. If QC equals to KSP, the solution is at equilibrium. If QC is larger than KSP, then you will see precipitate. Take a look at this question. It's from your textbook. Predict whether precipitate will form if you mix two solutions together. One solution is 75 ml of a sodium hydroxide solution with a pH value of 2.58. The other solution is 125 ml of a 0.018 mole per liter of magnesium chloride, and KSP of the magnesium hydroxide is this much. Okay, now based on what we discussed here, you have to know QC. How do we calculate the QC? Here's the thing. Step 1. First thing is, let's write the dissociation equation of the magnesium hydroxide. It's a solid, white solid, and if you dissolve that in solution, you will get magnesium 2 plus and 2 equivalent of hydroxide. Okay, so based on this, QC of this magnesium hydroxide equals to magnesium 2 plus concentration times the concentration of the OH to the square. So if we want to know QC, we do have to know the magnesium concentration in the mixture and the hydroxide concentration in the mixture. So step 2. In this step, we're going to talk about how we calculate the two concentrations. Now let's analyze this question one more time. You mix two solutions together, you got a new solution. And before you mix the solutions together, you got OH concentration from the sodium hydroxide and magnesium concentration from this magnesium chloride solution. After you mix the two solutions together, the concentration of those hydroxide and magnesium will change. So we need to use M1V1 equals to M2V2 to calculate the new concentration of those two ions. Let's focus on the hydroxide concentration first. Okay, so this is the equation we need to use. Now, hydroxide, before you mix the two solutions, hydroxide concentration can be calculated from the pOH value. So since the pOH equals to 2.85, that tells us hydroxide concentration before you mix the two solutions is 10 to the negative 2.58 and mole per liter. And if you do the calculation, it will show you the concentration of the hydroxide is 0.0263 mole per liter. All right, so this is a concentration of the hydroxide before you mix the two solutions. After you mix the two solutions, M1, apparently that would be 0.00263 mole per liter times the corresponding volume, and that is 75.0 ml. That equals to M2, which is what we need to calculate. V2 is the total volume of this new solution, so that would be 75 ml plus 125 ml. Okay, if you do the calculation, M2, which is the new concentration of hydroxide in the new solution, that is 9.86 times 10 to the negative 4 mole per liter. And we do the same thing for magnesium. M1V1 equals to M2V2. So before you mix the two solutions together, concentration of the magnesium is 0.018 mole per liter. V1, in this case, that is 125.0 ml. Okay, and again, M2 is what we want. And V2, again, that is 75.0 ml plus 125.0 ml. Alright, now if you do the calculation, the magnesium concentration after you mix the two solutions equals to 1.125 times 10 to the negative 2 mole per liter. Now, you know the concentration of hydroxide, you know the concentration of the magnesium 2 plus. Now, the step 3 is just calculate the QC. So QC equals to the concentration of the magnesium 1.125 times 10 to the negative 2 mole per liter. Okay, so basically we just need to put those two values in this equation times 9.86 times 10 to the negative 4 mole per liter to the square. Okay, don't forget about the square. And that equals to 1.1 times 10 to the negative 8. Now we compare QC and KSP. And KSP right here, so when you compare these two values, you will see that the QC is much larger than KSP. And based on our criteria here, you will see the precipitate forming from this solution. Alright, this is a video, and you let me know if you have any questions.